Here's an audio narration based on the provided electrical troubleshooting scenario. Let's break down the situation regarding the house possibly struck by lightning and the electrical issues they're experiencing. The dimming lights and the television turning off when the furnace or washer are activated point to a significant voltage drop within the electrical system. The fact that this started happening after a power outage a couple of weeks prior is a critical clue. Additionally, the complete failure of all their phones after the same power event also indicates a problem. While you didn't find any immediate signs of overheating or charring at the panel, that doesn't necessarily rule out a lightning strike or a surge. Here's a deeper look at potential causes and recommendations. First, consider a lightning strike. Even without obvious panel damage, a lightning strike can cause hidden damage throughout the electrical system, including wiring, appliances, and surge protection devices. This hidden damage can then manifest as the symptoms you're seeing. Second, a power surge is another possible culprit. A surge from the utility grid, perhaps related to whatever caused the outage, could have damaged sensitive electronics like the phones and contributed to the voltage drop issues. Third, don't overlook the possibility of loose connections or faulty wiring. Given the home's age and the limited grounding with only 2 branch circuits grounded, there could be intermittent connections or deteriorated wiring creating excessive resistance. This resistance would cause a voltage drop when higher current appliances, like the furnace or washer, are turned on. Now for recommendations. 1. A thorough electrical inspection is essential. A qualified electrician should examine the entire system, including wiring connections at outlets, switches, and light fixtures, and within the appliances themselves. They should use instruments like a multimeter and a voltage drop tester to pinpoint the exact location of voltage drops and check for loose connections or insulation breakdown. 2. A service upgrade is likely needed. The home currently has a 100 amp service, which may be inadequate for the electrical demands of an all-electric home with a furnace, washer, and other appliances. Upgrading to a 200 amp service would provide more capacity and improve the overall system's stability. This should also include replacing the panel and ensuring proper grounding throughout. 3. Improve the grounding system. Installing additional grounding rods and connecting them to the electrical service entrance will significantly improve electrical safety and reduce the risk of future surges. Modern electrical codes require more comprehensive grounding systems than what might have been standard when the house was originally built. 4. The damaged phones will need to be repaired or replaced. Since all phones failed simultaneously, it strongly suggests they were all affected by the surge and may be beyond repair. 5. Consider a whole house surge protector. This device is installed at the main electrical panel and helps to divert excess voltage away from sensitive electronics during a surge event. It offers an additional layer of protection beyond individual surge protectors at outlets. 6. A whole house voltage regulator could be beneficial. While not always necessary, if the voltage from the utility company is consistently unstable, a voltage regulator can help to maintain a stable voltage supply to the home, protecting appliances and electronics from damage. Additional considerations to keep in mind. It is vital to emphasize that diagnosing electrical problems accurately requires an on-site inspection. A remote diagnosis can only provide educated guesses. Advise the homeowner to contact their insurance company to report the potential lightning strike or power surge and the resulting damage. Their policy may cover the costs of repairs or replacements. Any electrical work should be performed by a licensed electrician who is familiar with local electrical codes and safety regulations. They should also verify the repairs are up to code with the local authorities as needed. Keep in mind National Electrical Code (NEC) Section 250.52 specifies requirements for grounding electrodes, and 250.66 details the size of grounding electrode conductors. A qualified electrician will be familiar with these requirements. Voltage drop calculations, as detailed in NEC Chapter 9, are used to size conductors to ensure adequate voltage at the point of use, typically keeping voltage drop below 3% for branch circuits and 5% for feeders. If, for example, the branch circuit is at 120 volts, A 3% voltage drop would mean the voltage should not drop below approximately 116.4 volts at the furthest outlet when the circuit is fully loaded.